Welcome to data analysis with Python. In this video, I bring you something very interesting. There's this ongoing argument with about which is better between Python and R and all of those things. For me, I have a sentiment for R. I mean, for Python, sorry. I've made attempts to learn R a couple of times, but for some reason, I couldn't just get on. I wonder why. Well, maybe I don't wonder why, but finally, I just settled for Python, and I really like the idea that it's Python I went for. But interestingly, in this video, I'll be talking about data visualization with Plotnine, which is quite not common in Python circles, but Plotnine, one advantage people claim that R has over Python is the fact that it has ggplot, the graphics are better and things like that. Guess what? Plot9 brings you R kinds of plots inside of Python. And that's a very lovely bridge. When I discovered it like 2 years ago, I was so excited. Like, yeah, so we can get R standard plots right inside Python via Plot9, right? So Plot9 is a Python data visualization library based on R's ggplot2 implementing the grammar of graphics. So the grammar of graphics. So the idea of grammar of graphics is that it allows users to create complex layered plots declaratively by combining data, aesthetic mappings, and geometric objects. So it's more like you can add any ingredients you like, you can add the verb and the noun and everything. That's why you talk about the grammar of graphics in this situation. So it is ideal for exploratory data analysis and customizable visualizations. So welcome, ladies and gentlemen, to data visualization Plot9. Okay. So here you need to set up the libraries, which can be quite a lot because there are many ingredients you can put into the plot. So first of all, we are using pandas, which is regular for data analysis. We are using matplotlib.pyplot because it's basic in Python, right? And we are using Seaborn not because we need Seaborn to visualize anything, but because we need Seaborn to help us get for Python inbuilt data sets like flights, tips, and all of that. Then we are using Plot9. Plot9 is a key thing here. Let me even separate it to show that it's the boss here. So from Plot9, we are importing all the possible ingredients we can add, all the syntax, all the parts of the grammar we need. So we have the ggplot itself, right? We have the aesthetics, we have the geometric points, we have the geometric line, we have the geometric bar, we have histogram, box plots. So here, the key thing is geom underscore whatever you're doing. Before it's in matplotlib, it is something something. It is plt.plot, plt.bar, plt. This and that. But here it is geom underscore that. So if you want point plot or scatter plot, right? I think it should be geom underscore point. If you want line plot, yeah, it's geom underscore line. If you want bar plot, it's geom underscore bar, geom underscore histogram, box plot, violin plot, call facet facet grid, and all of these things, right? So we call all of those right here. Yeah, let me remember to put the line numbers. That helps to reference stuff. Okay. So of course, don't forget, don't be carried away. Remember to run it. So this is what we have here. So we set up all the libraries here, and I press enter. So of course, if it doesn't give error, then we are good to go. Yeah, it means that all the libraries are in place. We have pandas, now we have matplotlib, we have seaborn, and we have plot9 with all the ingredients right there. Then the data set we are loading, like I said, we are using seaborn here, not because we need it to visualize, we just need to use it as a means of getting data sets out, like the flight data set and the rest. So I just run this. I'm not showing anything about the data set now. In the previous video, we did the info, the describe, talking about some kind of exploratory data analysis. But now no error, so we have the data sets mounted, flights, Iris, tips, and Titanic are now available for our use. So we now take the data sets one by one in this case. So first of all, we start with the flights data set visualization. So the flight data set records monthly airline passengers from 1949 to 1960. We've used it a couple of times, right? So this is the same data set we have right here. Okay. Then, so from based on that line data set, I want to do a line plot which shows us passenger growth over years, and we are going to color it by the months, right? So here, the file name, your file name, call it whatever you want to call it. So you have plot underscore flight underscore line because you are doing a line plot. So this is not a standard, like you can call it anything you like, right? What really matters is the ingredients you're adding. So we are using ggplot and we are using So ggplot, we are using the flight data set. The aesthetics, you want X to be the year, you want Y to be passengers, and you want to color based on the month, and then plus you want a line plus, so you say geom underscore line. Then you want minimal theme, you say theme underscore minimal plus labels. So when you say labs, we uploaded labs up there too. I think we have something like labs somewhere. Okay, do we have that? I think so. We don't have, yeah, we have labs exactly. So this is labs. When you say labs, it talks about labels, right? So for the labels now, so you have the title, passenger traffic over years by month. X is year, Y is passengers. Then the scale color underscore brewer. You have type is quality or QUAL, and the palette is set three. And then now how you visualize plot here is to say that plot underscore flight underscore line dot draw. So that dot draw is what makes the plot available. Okay. So you can now see for I mean for whatever month you pick, you see the flights are increasing year on year like that. So passenger traffic over years by month. So you have that going on right there. Okay. So the insight here is that passenger count steadily increased from 1949 to 1960, indicating growing airline travel demand for sure. Or you have more and more people embracing flying, right? At first, some people will be skeptical, they'll be afraid that, oh, how can something be like 40,000 feet uh, up there, and then what if it falls and all that? But as they see that they go faster to places and come back, then more people embraced that. So let's talk about average passengers per month by using a bar plot rather. So build a plot by saying plot underscore flight underscore bar. So you want to use a descriptive name that you can easily know what it is doing. But you can even use your name, but make sure you use something that you can easily identify. So again, the key things here, you have the ggplot, which is flight, the mean, you have flight underscore mean, all right? Then you have the aesthetics month, you have the passengers. So this flight underscore mean, of course, would be a standard because the flight data set underscore mean. So it tells you that you need the mean of the flight, right? But the aesthetics would be a month and the passenger numbers. Then you have the geometric colors. So geom underscore col, I have a reason to believe that it's about colors. So you want to have steel blue, so you can change the color if you like. So you see this plus plus. So it's more like you have this, you're adding the colors to it, you're adding the theme lights to it, and then the labels, average number of passengers per month, X is month, Y is average passengers, and then you use this line 10 plot underscore this plot underscore flight underscore bar dot draw. That gives you the picture. Okay. So what's wrong here? Flight underscore mean is not defined. There's nothing called flight underscore mean, right? Okay, so in this case, we may need to do um does this work here? Let me see. Flight dot mean. Does this work here? Does it? I know that's the standard in matplotlib. Okay, so I think we need to do mean before we come here, right? So it's necessary that we have done mean the average before we come to this place. Um, let me see if I can pull that off. So if I say flight underscore mean now, flight underscore mean, then we can call that here. So flights underscore mean should be equal to how do we sum the flights over the years now? Okay. Um so we have to group by the month and then we now find the average. I think that's what should happen. So that's flights dot group by I hope I remember the syntax. Group by month, and then we now find dot mean. Hopefully this works. This doesn't method object does not support item assignment. Mm, okay. So I'll correct this before I upload the file later. So I just know we need to get this working. Mm, I don't seem to remember the syntax for this. Okay, so I'll get this sorted before we go on later. Okay. So we have The insight we'll get from this is that July and August tend to have the highest average passengers because these are holiday and travel seasons. Then we have the Iris dataset visualization. So the Iris dataset visualization uh, contains measurements of three species. Um, okay, let me even see. We can let me show you. I can even show you one way. You can use AI to edit these codes. So I mean that's also one nice trick you can learn. So I use Grok in this case. So what I just is I just paste the data there. So it shows me what I've done wrong, right? So the code analysis. So creating the plots, displaying the plots. So okay. So it seems that what I don't think there's no difference between this and what I've done so far. Let's see if that works now. And then we now compare what I've done. Okay, okay, let me just copy this under here. I have this now. Group by month, mean. Okay, am I supposed to do this? Okay, let me cut this out first. Okay, that doesn't seem to solve it just yet. Okay. Okay, let me still go on then. So do we really have to reset the index dot reset underscore index this? Okay, now this gives a bit of idea. I mean, I think this tends to work a bit better. Right. So this helps. So of course you see July and August do the number. So July and August tend to have the highest average passengers. So by holiday and travel seasons. So you can use AI to, of course, debug your code and all that. So even if I want to remove all these things now, I can still. So all you just need to do is this error message. You just copy and paste it under that. So you don't want because you don't want sometimes the error messages just rise up and they don't really affect the result, but you just don't want to see the error sometimes. So just fill in that error thing. Okay, then it's about some operation on the code that is not okay. I think by just putting this false thing here, it works. So we now have the updated code. So I just bring this back over here. Control A, Control V. So enter. Yeah, the error is gone. The error is gone. And what has happened there is that we have flight.group by month, then observed is equal to true dot mean reset index. So you calculate by month and calculate mean, silencing the warning. So observed true. So by this now, you see that of course, as expected, the highest flights are in July and August. Then we can go for the iris data set. The iris data set contains measurements of three iris species, not iris now, it's flower iris. And the three species are Setosa, versicolor, and virginica. So we can see the top 50 of this now. So we see their sepal length, sepal width, uh, petal length, petal width, and the species like that. Okay. So the top 50 are all Setosa because it's 50, 50, 50, 50. So to see the first 50 and the first five and the last five, we could just do this. So okay, iris.head. Okay, showing us just the top four. Yeah. Okay, this is what I meant to do. I just want to see iris so you can show top five and last five. Yeah. So we have Setosa Virginica. So in between somewhere. So the top 50 is Setosa. The next 50 is what's that thing now? Is Vesicola, and the last 50 Virginica. That's why we have it this way. Okay. So we have scatter plots. Now we want to do sepal length versus sepal width and just a plot underscore iris underscore scatter. And oh, did I talk about this a little bit more? Okay, I mean you just add up ggplot, the flight mean, blah blah blah, and all that, the aesthetics, the blue, the black. Okay, coming here, so you have ggplot, you have the iris data set, the aesthetics about sepal length on the X, sepal width on the Y, the color based on species, geometric points, you have size 3, alpha, 0.7 plus the theme classic plus the labels, and then you have your scatter plot this way. So you see the scatter plot is a bit more beautiful here, or so I think, you know. So it's giving the normal R vibes, the ggplot vibes. So the insight is that Setosa species are well separated. So the Setosa species are all these red kind of things. So they are well separated, and Versicolor and Virginica overlap. So the Setosa, they stand out. Versicolor and Virginica, they have similar behavior. So, but the Setosa species seem to stand out when it comes to the sepal width kind of thing. So for the box plot, so you want to do polar plot underscore iris underscore box, ggplot iris AES species, Y petal underscore length, fill with species. Then you want to do geometric box plot with alpha 0.7 plus minimal theme and labels as you have it there. And then to draw, you have plot underscore iris underscore box dot draw. And this is what you have. So you have some very pretty box plot here. So you can even see you can see outliers below and above for the Setosa. You have below for Versicola and no outliers for Virginica, like that. So you have petal length distribution by species now, right? So here you see that Setosa has much smaller petals. As you see, the median petal length is really is below 2 compared to species Versicola that's above 4 and Virginica that is almost 6, right? So Virginica has the largest petal length as clearly seen here. So we have the TIPS dataset visualization. We've worked with this all over time. So total bill, tip, sex, smoker, yes or no, day, Sunday, and all that. Time, dinner or lunch size is 2 or 3 or whatever. That's the group size coming to eat in the restaurant. So plot on that. So here we need scatter plot. So we just say plot underscore tips underscore scatter. So that name is not what makes it scatter plot. What makes it scatter plot will be your uh the geometric point here, right? you know. So you have, because you are plotting points basically. So you have ggplot, you are using the tips data set, the aesthetics, X is total, BY is tip, the color, you are coloring according to time, the come, whether it's for lunch or dinner, geometric point, we are doing scatter plot, so it's more like we are plotting points, scatter plots. So we are plotting the points alpha 0.7 plus the theme is minimal, then the labels, you do all that. Now, here we want to explore what exactly is this alpha 0.74. What if we make it 0.5? What changes? So that's how we learn, right? So what has changed because of that? So what if we make it 0.005? So maybe make it something really ridiculous. Yeah, it's about the points. It's actually about the points. So I never really paid attention to what that is about. So you see the points are showing up now. So what if I make it 0.75? You have it. So the bigger the points, so let me see if I can make it even one. Is it possible to have it as one? Yeah. So it's about this dots you have here. So it's about the point 0.7, like what we had. Okay. So now, so you can see we have, so the insight here is that larger bills usually generate larger tips. Of course, that goes without saying because tips are proportional to tips. Uh, Tips are proportional to total bills. So, but lunch and dinner have different patterns. So you see, lunch and dinner, when it comes to lunch and dinner, the patterns are somewhat different when it comes to the tips. Right? So because if you look at the lunch, right, it's not as steep as what you have for the dinners, okay, like that. So you can also do violin plots where we consider things like total bill distribution by day. So how did the bills go according to the day? So we are doing violin plot now. So we have geom underscore violin, right? That's the key thing here. And we do the normal ggplot things in R and the labels and the theme. So here now uh the wider spread seems to be with is it on yeah, on Thursday for sure. So Insight, Saturday and Sunday have wider bill distributions. Really? Saturday and Sunday have wider bill distributions. Are we talking about wide width in terms of this? That's a bit so possibly larger groups dining. Could that be it? Okay, maybe the distribution is on the is vertical, not horizontal like this. So like okay, Saturday, could it be like this length? So I would naturally think it's all these copy parts, or maybe that I need more clarity on that in the future. So Titanic dataset visualization also, the Titanic dataset record survival data from Titanic disaster. Here, the tips data set, did you say something about that? It's actually, okay, I didn't say anything about it. Okay, I guess. But of course, we know it's about people going to eat somewhere and then they pay bills and they pay proportionate tips based on the bill they pay. So counts of survivors now. So plot Titanic underscore survival. So we are doing bar plot here, geometric underscore bar, right? And then we do the labels Titanic survival counts. X is survived, zero for no and one for yes. Then Y is the number of people that survived and everything. So the X here is the factor that survived. So for number of people, right? For those who survived, zero. So more people survived than, I mean, more people did not survive compared to the number of people that survived. So if one is for those who survived, so roughly something like between 200, around 350 people survived, but about 600 or so people uh, did not survive. More passengers died than survived in the Titanic disaster. So like that. So we have faceted histograms too, where you can talk about age distribution by sex. So here, of course, because I am bringing in um okay, for the Titanic data set, right? There are some missing values and everything. So we are doing some kind of data cleaning here. So missing values in age column summary. I mean, so basically we are doing data cleaning. That's what is happening here. So so for the data cleaning now, we are dropping not available values. You can also replace with median and all of these things. So you can, if you want to uncomment to impute instead of dropping. So if you don't want to drop and you just want to impute values, we've done something like this before, so it's not a problem. So you can also verify data and missing values after cleaning. So to see that you have done a good job. Then after all the cleaning, you can now go ahead and create the plot with cleaned data. So plot Titanic age facet and then ggplot the clean data set you have generated, and the aesthetics is about the age. Then you are doing histogram with bin with 5. So the bin talks about how wide the bar is in your histogram. I've done that before. Fill is summoned some kind of color thing, and the color is black. So facet trap is about the sex, team light, and then you do the labels, and then you use plot underscore Titanic underscore age underscore facet dot draw, open brackets, close brackets do the to run the stuff. Uh, what's happening here? Okay. Yes. Yeah, this is where we are at. So yeah, so we do this now and we have this now. So you can see the ages have been done. So you see that here we're talking about age distribution by gender. So you see that you had mostly you have more of males between ages 20 and 40. So in fact, mostly males in their 30s, you had them there. So many young adult males were on board compared to adult females, right? That's the deal. So you have 0-year-old children, both male and female, and you have very elderly people. In fact, you have 80-year-old males and you have about 60 to 70-year-old, between 60 and around 65-year-old females, right? Right. So but you have mostly men in the adults in their 30s, like that. So let's talk about some advanced plotting techniques as far as Plotnine is concerned. You have multiple layers. For instance, you want to do scatter plot plus smoother line. So you need say you want to fit a linear regression to it, right? Like you have scatter plots, but sometimes you don't to get a specific thing about the line of best fit, you need to fit it to know what the line looks like, right? So this is it right here. So this is for the linear regression, and we are using ordinary least square for that. And we are doing tip to total bill. Data is tips dot fit. Then extract slope and intercept. So you get the slope, you get the intercept. That can give you the equation as you see here. Let me bring back the line numbers. That always helps us to for referencing. So line 11 is helping you to get the line equation for the line of best fit. And then, of course, you now have the plot tips advanced, ggplot, we are doing points, we are doing smooth lines and all that, as we've always done. Okay. Geom is not okay. It looks like because of what I did, I have to go back and rerun this. Okay, I think that's a challenge. And I also have to rerun this. Okay, I think with this we should be good. because I went out and I came back later. So that's why this is not happening now. So we have the line done. So what's the challenge now? Geom smooth is not defined. Really? Why? Geom smooth? Okay. Don't we have Geom smooth up there? Geom smooth. If we don't have it, we can easily add it. Let us say geom underscore smooth. So we can add it right here. Okay, I need a comma, right? Good, that works now. So then I go back to this. We should have it working now. Nice, so it works. Yeah, so we have a line of best fit, and the equation of that line is 0.11x plus 0.92. So we have a positive slope. So it means that the higher the total bill, the higher the tips. Goes without saying for sure. So there's a positive linear relationship between total bill and tip size. That's what that tells us. Then we can have a complex facet grid. So Titanic survival by gender and class. So how did you people survive on the Titanic? So you have plot underscore Titanic underscore facet grid. So you have GG plot Titanic drop any. So any non-available data, you drop it. So it's more like you're doing the cleaning right inside here. So, and you have factor survive, factor P class. So these are the group things with which you are grouping. And then we are doing bar, geom bar, position dodge plus facet grid, sex going according to P class and so on, like that. And then you just run this. And so this gives you some clarity that you have survival by gender. So more females survived, right? First class women had the highest survival rates, right? So you can even see that even more of females in first class survived compared to males. Even more of females in first class survived, right? You know, so first class women had the highest survival rates, and the lowest survival rates, I think, is among women in women in second class, I think, at least compared to men in second class, right? Like that. So if you want to look at the longest and the shortest, I think that's about it. How do you save in Plotnine? So, Plotnine gives you Pythonic, it gives you R vibes inside of Python, right? So saving in Plotnine, saving a plot to a file can be done using the ggsave function. So this is a new one. So so far we've done matplotlib and seaborn, and we keep using the same uh, plt.savefig and all that. So but here we have ggsave for plotnine. So in plotnine, saving a plot to a file can be done using the ggsave function. So this function allows you to save the plot to various formats like PNG, PDG, PDF, SVG, or JPEG, and provides flexibility in setting the size, resolution, and other properties of the output. So the syntax is usually something like from plotnine import ggsave, and by the time you want to save, you now say ggsave file name, plot is none, DPI 300, and you can vary all these things. So you can save in different formats, by the way. So plot iris, maybe you want to do a scatter plot, and then you want to plot in PNG, PDF, and SVG. Of course, PDF and PNG, they are very good if you want very high quality stuff. If you are doing something on the web, SVG is cool. So you have ggplot, iris data set, aesthetics, X is sepal length, Y is sepal width, color is species. You want to distinguish based on species, geometric point, size is 3, and alpha is 0.7. How you want those line points to be like, and then we have all the labels. So if I enter this now, ggSave is not defined. Okay, that means we need to import ggSave. So maybe what I need to do is I need to bring this here. So anytime you have something not defined, it means that you have not run it somewhere before. So I bring it here now, and then I don't have that problem again. Though these are looking like errors, but all these plots now we have them. We have plot iris underscore iris sepal plots PNG. So we can go into the file and see that iris. We can come here and we find, yeah. So you have all this iris stuff now. Iris sepal plots. This is a PDF. Okay, we have. Then we come back here. We have iris sepal plot for PNG. Okay. And then we have the SVG, which is good for web, right? So that goes. So we have that done. So you can also save multiple plots, right? So plots, iris scatter, plot tip scatter, plot Titanic survivor. So you want to do all these plots at once, right? So I mean, these things have been declared before, so we just want to save them in using just one cell like this. So you now say for I, plot in enumerate plot comma one, dg save plot, file name f plot. So this is like f string now, plot I. So you plot one, two, three. So it means you are reading this whole Python. This is a Python list. Now you're reading through the list. You're iterating over the list. That's the word. So with this now, it means you have those three out there already. So you're going to have plot one, plot two, plot three. So we go into the file again, and then you see plot one, plot two, plot three. And that's how those are. Plot one, plot two, plot three. Like that. And then we come back here again. So these are the key lessons we've learned so far. So it gives you for those who are used to R, these are things you've always been using in ggplot too. So you have the geom point for scatter plot, geom line for line plot, geom bar for bar plots, which helps for counting, geom call for bar plots and with their values, geom histogram for histograms, geom box plot for box plots, geom violin for violin plot, facet trap for small multiples, 1D faceting, facet grid for gridded multiple plot, 2D faceting, theme underscore whatever for different theme styles, labs for titles, XY labels, and captions. GG for to save plots, right? So if you are really if you do R a lot, you can use Plotnine in Python, and that makes your work beautiful. Okay, so this is the end of this video about data visualization with Plotnine, which gives you R vibes inside of Python. So let me know how helpful this video is for you. And if there's something you like us to do, like you want us to teach a topic or solve a problem, you have a kind of data set you want me to work on, whether you have the data set and you want to send it, or you want me to generate a particular kind of data set and use it as an example for your understanding, I can always do that. If you have not subscribed, you are missing a lot already. You can be sure of that. If you have subscribed, thank you. And don't forget to hit the notification bell so you can always get alerted each time a new video is released. And be sure to like and share so that more people can have access to this great content I have going on here. Till I come your way again, keep doing data right. Bye.